Alright, here I am with a sample FRQ3, and just like I did with the previous FRQs, FRQ1 and FRQ2, I will be teaching you how to tackle any FRQ3 in particular rather than pertaining to the specific question that we have right here. So let's move ahead. Now, before we start FRQ3, I want you to understand that FRQ3 is not the easiest of FRQs, unlike FRQ1 and 2, which were relatively straightforward. You need to understand the question, you need to understand each and every sentence, and only then will you be able to score full or at least good credit on this FRQ3. I'll start reading it now. The tire of a car has a radius of 9 inches. So I'll have a tire of a car in the shape of a circle with radius 9 inches. And a person rolls the tire forward at a constant rate on level ground. Point W on the edge of the tire touches the ground at time t equal to half of a second, which means if I have my point W somewhere here, and after I rotate my tire for half a second, my point W will come right here after rotating, which is touching the ground, and only one point can touch the ground at a time, which is the tangent to it. The tire completes a full rotation, and the next time W touches the ground is at time t is equal to 2.5 or 5 over 2 of seconds. So the first time W is at the ground is 1 over 2. The second time W comes on the ground is 5 over 2. Now, if you have basic intuition, then you should be able to figure out that 5 by 2 minus 1 by 2 gives us 2 seconds, which means that one full rotation is of 2 seconds. The maximum height of W above the ground is 18 inches, which is quite obvious since we know that the radius is 9, the diameter would be 18. As the tire rolls, the height of W above the ground periodically increases and decreases. The sinusoidal function h models the height of point W above the ground as a function of time in seconds. The graph of h and its dashed midline for 2 full cycles is shown. 5 points, blah 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 blah, are labeled on the graph. Determine the possible coordinates t, h of t for the 5 points. Now I'll move to another slide to draw the diagram a bit better so we can analyze the possible coordinates of the following points. Now I have the graph with me here and the 5 points which we have to figure out. Now we know that our coordinates will be of the form t, h of t, where the height is modeled as a function of time, and then we have time itself as our y coordinate. Now we know that we so far know only three possible heights, which are 0, 9, and 18. And not just in this FRQ, but if you refer to any FRQ in particular, you will find that they give at most three y coordinates. They may give you two and they leave the third one for yourself. Because, for instance, they might not give you the 18 one, and you'll have to figure out that, hey, what can the maximum height of W above the ground be? And in that case, you can simply figure out that if I have a radius of 9, then the maximum height would be at the top right here, which would be 18, right? So that is how you can figure out your third point. And now that you have your 3 points in this question or in any other question, you'll always have three dotted lines in your FRQ3, and I want you to immediately mark them down. So I'll have 0 here, 9 here, 18 here. And that's it. We have solved for the y coordinate. We know that the y coordinate for f is 18 right here, g is 9, g is 0, k is 9 again, p is 18 again. And that way, we have very simply solved for the y coordinate of f, g, j, k, and p. Now, what about the x coordinate? We know that in the question we're given that w has a height of 0 above the ground at time equal to half second, 2.5 seconds, 4.5 seconds, 6.5 seconds, and so on. Now, which of these times are you supposed to choose for j? It could either be 1 by 2, it could be 5 by 2. What will you choose? And if you pick a 1 by 2 here, then you will have negative x coordinates for f and g. And while that is allowed on the test, you will not lose credit at all. I prefer you work with positive values. That way you don't mix up the terms yourself. So if I choose 5 by 2, remember, even if I choose 1 by 2 or a 13 by 2, it is all perfect. But say I choose 5 by 2. I write the coordinates of G as 5 by 2. Now, if I have my circle, if I have my wheel right here, I know that if I have four distinct points of W, one is here, which is 18, one is here, which is 0, one is here, which is 9, and the other one on the way back is 9. Now I know if one complete rotation takes 2 seconds, then how much would 1/4 would take? And that is exactly half, right? So half a second later, my W will be at height of 9. Another half second later, I'll be at 18. Another half second later, I'll be at 9 again. And at the last half second, which completes 2 seconds, I'll be back to 0. So I'll go on subtracting half. So if my J has height of 0 at for W at J, then if I subtract half, I'll be on, let's say, 2, right? The x coordinate of G would be 2. The f coordinate would be 3 over 2, which is 1 half. And if I add 1 half over here, I'd get 3 here. And I'll get 7 over 2 here, which is 3 halves. And that way, I have figured out all the points. That is how simple it was. The y coordinate is the really easy part. The x coordinate, you have to figure out how much would each fourth of an interval, or in some other cases third of an interval take. And once you get that point, you take the main point which you have, which is given, and then you add or subtract accordingly to get the other 4 points. I hope this was very clear because this is a bit tricky. Now in part B, they ask us the function h can be written in the form h of t, which is a times sine of b times t plus c plus t, where our concerned angle is t. It would be better if they give that as a theta, so students are clear with the constants, but nonetheless, they mention that find the values of a, b, c, and d. Now we have learned before that a is actually the amplitude, b is the frequency, c is the shift, and d is the midline. So whenever you're dealing with these questions, go from the beginning and answer them independently. And so if I start with A, I know A is the amplitude, which is the maximum value minus minimum value over 2, which is 18 minus 0 over 2, which is 18 over 2, which is 9. So we know that at A is 9. So I'll write down A as 9. Now what is my B? We know that the periodicity is given by 2 over B, which in this case is 2. So if I move 2 to the other end, I have B as 2 pi over 2, which is pi. So B is pi. That was quite easy. Now what about C? Now there is one important point that I want you to know. A cosine function always starts from the origin. So cosine function would start from here, go up, come down, and come back to the x-axis. That's how a sine function would look like. But if I talk about a cosine function, then a cosine function would start at the maximum point, come down, come back up, and end at the maximum point. That is how the graph of a cosine would look like. Now, when you're trying to adjust your constant C, remember that if you have a sine value in the question, then your first point should be at the origin. If you have a cosine graph to deal with, then your first point should be the maximum point. Now, in this case, we could either have g, k, or the future values to be at the origin, but not this one. So what I'll do is I could either have c as -1, which will essentially move the entire graph right here, which means that g will end up over here. Or I could even take a -3. This means that k will end up here. Again, I want you to convey the goal of shifting the graph to the left, which is to understand that the sine function originates from the origin, right? And that is why we need to shift it -1, -3. In fact, if we take any 2k minus 1 integer for an integer k, 2k minus 1, then they will accept this as your answer. And finally, d is the equation of the midline. I don't have a lot of space left. D is the equation of the midline, and we know the midline in this case is y equal to 9. So my D is simply 9. So again, my A is 9, D is 9, B is pi, and C could preferably be -1 or -3. But if you write any integer of the form 2k minus 1, the people who check the papers are good with it. So yeah, we're good. Let's move ahead. Now the part C is refer to the graph of H in part A. The t-coordinate of K is T1, okay, they are considering the point K, and the coordinate of P is T2. On the interval T1, T2, which of the following is true about H? So we are concerned with this interval. This is point K, this is point P. They are concerned with this interval. And now understand that H is positive, right? This is 0, 9, and 18. And H is obviously positive. So you cut down the other two options immediately. I am left with increasing and decreasing. Now, you will notice that the interval right here, okay, the function is increasing. The function is increasing, but the rate of change is decreasing. I hope that was clear, okay? You see, the function is still increasing throughout the interval. It's going up, 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 but the rate at which it goes up suddenly slows down, and when it is about to decrease, the interval ends. So what you can say in part 1 is that A is the correct option, where H is positive and it is increasing. This is the correct one. And in the second part, describe how the rate of change of H is changing on the interval. Now, do not be in a hurry. If you look at, oh, how is H changing on the interval 1, T1, T2, and you say, hey, I just wrote that, H is positive and increasing. But it says describe how the rate of change of H is changing, which means I'll write because the graph of H, because H is concave down, which is obvious since if I join 2 points, then the entire graph lies above the secant line. Because H is concave down on T1, T2, the rate of change of H, the rate of change of H is decreasing on the interval T1, T2. I hope that was pretty clear. And here we come to the end of FRQ4. Yeah, this is FRQ3. Oh my god. Yeah, here we come to the end of FRQ3. I hope everything was clear. If there are any doubts, message me in the comment section below. I'll reply as soon as possible. Thank you and have a good day ahead.